Okay, so we're talking about 7-7 in the inverse relations and functions. Now, I know you don't know what an inverse is. A relation is just any set of ordered pairs. So, any set of ordered pairs. Um, well, the inverse is found simply by switching x and y. I know that seems like it's too easy and too simple, but really that's all it is. If you know how to switch x values and y values, then you will have the inverse down. So for instance, in this particular example, I see example 1, it says find the inverse of, and it lists 3 coordinates. This is a set of ordered pairs, so this is what we would consider a relation. Now, it also happens to be a function because it passes the vertical line test. If you would actually graph these out, you'd see that. But finding the inverse is as simple as switching the x value and the y value. Nothing more complicated than that. This is called the inverse. Okay? So don't think it's some complicated thing that you can't figure out and don't know how to do. Do not multiply everything by -1. I get kids that multiply, they go -1, -2, 3, -4, -5, +1. That is not what we want you to do. So please make sure all you're doing is switching the x values and the y values. That's it. So this would be the inverse. Okay? Now, I'm going to graph the original function. Okay, see the original one we had 1, 2, and -3, 4, and 5, -1. Okay, those are my original coordinates. Now, if I graph the inverse, okay, and I'm going to use a box for those. 2, 1, 4, -3, and -1, 5. Now, I don't know if you realize this or can see this, but if you drew the line y equals x, right, slope 1 goes through the origin, right through the middle there, you would see that these are matching points. They are reflection images straight across this line and landing on the other side, on the opposite side of that line. So whenever we go from any set of ordered pairs to its inverse, we're switching x and y, we are reflecting across the line y equals x. All right? That's exactly what's happening on the graph. Now, what about domains and ranges? Well, in our original set of coordinates, which you can look back in your notes at, we had a domain value, x values of 1, -3, and 5. And the range values were 2, 4, and -1. And if you were to do a mapping, remember how the mapping diagrams looked way back in chapter 1? We would draw arrows from every value in the domain to every value in the range. This one went with that one, and so on. Well, what are the domain and range of the inverse? Well, think about this. If you switched x and y, you should have also reversed the domains and ranges. So now 1, -3, 5 is the range, and 2, 4, -1 is the domain, right? And these values go with these values. Okay? So domains and ranges switch just like the x's and the y's. Okay, let's take a look at example 2 and 3. They're kind of together. It says find the inverse of y equals x squared plus 3. All right, now here's an equation. It's not just a set of coordinates, it's an equation. So the first thing I want you to do is I want you to switch x and y. Technically, you have found the inverse. But math teachers, being the anal people that we are, we want you to solve for y. So every single time I will ask you to solve for y. So think about what you need to do here. We're going to move the 3 to the other side. So that makes x minus 3 equals y squared. Now, how do I get rid of the square? Take a square root, right? And when I do that, right, even root in a solving situation, I get plus and minus square root x minus 3. Now, if you want, let's graph the original one. The original graph was x squared plus 3. That's a parabola that's been shifted up 3 units. And I'm just going to draw it generically. Okay? Well, keep in mind, right? Remember you got that line y equals x. And you know that we just said that every time you switch x and y, you are reflecting across that line. So in other words, the starting point here is now over here for the inverse. So this has two parts. It's got the positive version, and that looks like this. This is positive square root x minus 3. And it's got the negative version, right? That's negative square root x minus 3. We're going to talk more about graphing those individual parts in the next section, but you can clearly see that it's a reflection across the line y equals x. I know I just sketched it and I didn't graph individual points very specifically, but you kind of get the idea. You're just switching across that line. Okay, just for fun, let's do another inverse. What's the inverse of y equals 3x minus 10? Totally different problem. We switch x and y, and we start to solve for y, right? So we add 10 to the other side. So we have x plus 10 equals 3y. I know most of you are going to divide by 3, and that will be correct, right? Y equals x plus 10 over 3. You might also see, and you better be prepared to understand, that this is the same answer, right? 1 over 3 times x plus 10 over 3. That's what that says. X plus 10 all over 3 is the same as 1/3 x plus 10/3. You got to be prepared and understand that that means the same thing. Okay, so either one of these would be considered okay for the inverse. Okay, next. Example 4. It says, find the domain and range of this function. Well, guess what? It would be really nice if I had a picture. So I will draw a quick picture for you of this function. All right? It is the positive square root. Positive square roots always look kind of like the top half of a sideways looking parabola. But this one has been shifted. Which direction? This has been shifted left 1 unit. So we are going to start over here, and it's still a sideways, top half sideways parabola, but it starts at the coordinate -1, 0. Because it's been shifted to the left 1 unit. Looking at the picture helps me understand about domain and range. I know many of you are going to get frustrated and say, I don't know how to do domain and range. Look at the picture. What's the domain? Well, from the picture, I see that the farthest x value here is -1 on the left side, but it has all the x values continuing on to the right forever and ever and ever. So I want to say x is greater than or equal to -1. Another way we can do that, folks, is to realize that anything under the square root symbol has to be bigger than or equal to 0. Anything under a square root has to be bigger than or equal to 0. And when you solve this, you end up getting that domain. Now, what about the range? Clearly from the graph, I can see that the smallest y value on the graph is 0. So, and it just keeps getting bigger and bigger and bigger, and I know it doesn't just shoot up through the atmosphere, but it just will continue to gradually get bigger and bigger and bigger and bigger and bigger all the way out. So this is y is greater than or equal to 0. Now, the next question says find. Now this notation that you see here, f with the little -1 of x, that is read f inverse of x. So if you happen to be at parties and you see that on a t-shirt, you'll know that how to read that, f inverse of x, and then nobody will make fun of you. So f inverse of x, well, f of x, what? That is a fancy way to say what? Y, right. So y equals the square root of x plus 1. Switch x and y. Solve for y, right? So I'm going to square both sides. So I've got x squared equals y plus 1. And I solve for y by moving that to the other side. So y equals x squared minus 1. How do I want to write that? I want to write that, because of the instructions, I want to write that f inverse of x equals x squared minus 1. Alright, that's the way I want to write it. So even though we used y kind of in our way of solving it, when I get my final answer, I want to say f inverse of x equals x squared minus 1. Now, what's the domain and what's the range of this function? I know that that's part C. What's the domain and what's the range of f inverse of x, which was x squared minus 1? Now, I know if you graph this out, many of you are going to think that this is a parabola which has been moved down 1 unit. But that is not quite correct. Keep in mind what the old one looked like. Remember what the original one looked like? If you switch x and y, alright, so this was the point -1, 0. So now that will be the point 0, -1. All of the matching points across this line y equals x will give me a shape that looks like this. Looks like the right half of a sideways parabola. Here, let me give you a cleaner looking picture from what I just drew. The right half of a sideways looking parabola. So what's the domain? The domain would be everything, all my x values starting at 0 and going to the right. My range would be all my y values starting at -1 and going up. Oh my goodness, if you look at it, you'll notice that the domains and ranges switched places. Now, do not switch x. X is x and it goes with domain, y is y, it goes with range. But you'll notice that I had x greater than or equal to -1 here for the domain, and so the range value down here is y is greater than or equal to -1. So they really just reversed places. But keep in mind, x goes with domain, y goes with range. That is not changing even though you're switching x's and y's. Is the inverse a function? How do I know? Good old vertical line test. Yes, f inverse of x is a function because it passes the vertical line test. If you want to abbreviate VLT, I'll take it, okay, because I know what you mean, vertical line test. Okay, example 5, if you look in the book, it talks about this formula, d equals r squared over 24. They say that d is the distance when you have a car and its brakes are locked and you're skidding to a stop. So d represents that distance and r is the speed. Now, here's what I want you to understand about these story problem situations. The idea of finding an inverse in this situation really amounts to just solving the equation for r. So, if you can solve this equation for r, multiply both sides by 24. Right? Just going to multiply by 24 on both sides, and the 24's cancel over. Take the square root. Then you pretty much have, and yes, I know we could rationalize that a little bit more, right? Because there's a perfect square trapped inside. So I guess it would be 2 radical 6d if you were going to simplify it all the way. But that's all you're really doing with these story problems. So don't get hung up on switching r and d and solving for d. Okay? Just solve for the other variable. Now, the next topic of discussion, it's a property that you need to know. It says if f and g, two different are inverse functions of each other, then a really important property is f of g of x is the same as g of f of x, which is equal to x. Now, I know that doesn't make a whole lot of sense, but what it's saying is when you do the composition, you start with x and you end up with x. You start with x here, you end up with x. You do not start with x and then end up with x plus 2. You don't start with x and end up with x squared. You start with x and you end up with x. So, in example 6, I got a few parts here, but the first part I want you to do is help me find f inverse of x. Okay, so let's see here. We're going to use y equals x minus 7 over 6. We're going to switch x and y. And we're going to solve, right? We're going to multiply by 6 on both sides. So we have 6x equals y minus 7. And then we're going to move that to the other side. So y is equal to 6x plus 7. So that is f inverse of x is 6x plus 7. Now, I want to use these two equations to answer some questions. Okay? F inverse of f of 2. So f inverse, okay, let's start with this. 2 gets plugged into the f function, right? We know how to do that. F of 2 is equal to 2 minus 7 over 6, which would be negative 5 over 6. Now, what do you get when you plug that into f inverse, right? Well, we have 6 times negative 5 over 6 plus 7. Well, the 6's cancel. We'll zoom in on that a little bit. The 6's cancel, and that leaves me with negative 5 plus 7. Negative 5 plus 7 is 2. I want you to notice something. I ended up with the same value that I started with. I know, super duper cool. That just means that these are inverses of each other. So try it again the other directions. Take 5 and plug it into f inverse. F inverse of 5 is 6 times 5 plus 7, or 30 plus 7, which is 37. So now I'm going to take that value and plug it into the f function. F of 37. 37 minus 7 over 6 is 30 over 6, which is 5. Oh, look. I got the same value that I started with. That must mean, or showing me, that they're inverses of each other. So what do you think I'm going to get when I take f inverse of f of x? So in other words, the f inverse function tells me to multiply by 6 whatever I put into it and add 7. That's what it said right here. We found that out, right? 6 times whatever you put in plus 7. So what are we putting in? We're putting in f of x, the original function, x minus 7 over 6. Oh, look, the 6's cancel. That leaves me with x minus 7 plus 7. The 7's are going to cancel. So that shows me that I started with x and I ended up with x, right? Because the 7's canceled out. And that's all of our notes for section 7.7. There's a lot of examples I'll probably need to do in class with you.